All right, welcome to our webinar on rethinking the software development lifecycle, which I flipped the letters, but you know, the goal here is playing to win in an agentic transformation, and there's a lot of noise and a lot of complexity in this space, and it can be feeling daunting, and you can feels like gaslighting almost. Every message is different, and we made a decision about a year ago at Rangle to focus entirely on earned experience. So the work we did and what we learned from it, and reapply it. We had 12 years of doing scaled lean agile development in large companies. We had a very strong design system practice. So the idea of removing complexity and cognitive load from teams who could work on delivering software faster has been part of our sort of DNA and our mission over the last 13 years, 12 years, a little more traditionally. And so, from a software lifecycle, we have a lot of strong opinions. We've applied our opinions and our sort of models in large companies all over the world, whether JetBlue or Uniqlo or Kenvue, E-Trade, multiple banks, startups. So, we've done projects from 2 weeks start to finish, where they're in production, and we've done projects, that have been multiple years. Our longest enterprise engagements, have run over 5 years with different clients, insurance, banking, and whatnot. And so we understand all of the telco, the interesting things that happen in complex projects. So we're not naive about it, and we're not a bunch of vibe coders. And we have a very, I like to think, elite development team, both on the front end and cloud native architecture. So we have a lot of strong opinions internally. And so, the earned, not learned experience, and then sort of the three foundational takeaways based upon 12 years of scaled lean agile work and 30 years of work across enterprise software in different domains. And so, you can't really talk about a software development lifecycle without sort of stating opinions and background and some of the foundational stuff. So this is going to be maybe a tad more academic or detailed than you might see on a TED talk. I don't have pictures of mountains and green fields and sort of cool things to anchor the emotional tone of the talk, but there's a lot of, I hope, good information. And I'll state, I've never really seen a good specification. Almost all of them get thrown out. I've been on projects with large footwear companies where they spent a year with a team of 50 people putting together specifications. They threw them all out. I also worked at a large consumer packaged good company. I came in after that year, just to be clear, and the same thing. So you put a bunch of people in a room, you tell them to write things down, they start writing it down, but it's not validated easily. Whoever's in the room is directing the conversation. People really don't want to spend a lot of time reading 50-page functional specs, and it just doesn't really work. And so what Agile did, I think, quite powerfully, is it really emphasized validation, and that's one way of thinking about it. I think most organizations don't think of it that way. They think of it as self-organizing teams and lighter weight processes. But ultimately, the heart of Agile is working software and validation of hypotheses in a lean startup model, validation of the requirements, and anytime that you sort of insist on getting it more right up front, the slower the process goes, and the worse the software outcomes. So personal bias anchors a lot of the following. And so, the only viable agentic software development lifecycle, and agentic or otherwise, it's the management of attention and context, human and agentic, and against working software is the source of truth. Whether doing a waterfall process, getting the attention and the specifications and the validation, and then building the software and validating it, or an agile methodology, and this becomes important. So, where we put our attention, this is the problem in management. It's why large companies become more bureaucratic. The higher you are in an organization, you have less degrees of freedom. and you're managing the organizational structure and indirectly creating outcomes. That's why transformations are really hard. There's a lot of context that goes into how we do our jobs, and the same comes into any complex system. And I think lean agile is foundational to agentic because you need to manage such a high amount of complexity, and you need to manage attention. If you can move to continuous validation of working software, you remove a lot of the complexity. But that then becomes the problem to solve. And this is where you'll see some developers actually are negatively productive with AI because they need to read everything, or they could be productive, but they won't write a single line of code until someone gives them a spec. They're used to being given all of the information, the designs and the functional requirements, and implementing them. So now you have an agent that is actually bringing some of that intelligence, and you're not leveraging it if you're trying to make everything come up front. And yeah, so lean agile is foundational due to the complexity we're dealing with, and it's foundational in the same way that it is in large systems. There's just too much noise, too much complexity, and so what we want to do is narrow our attention to what's next, what's most valuable. Build and ship that, validate, and continue to move through the process. And we will do more enough work to let that be successful. And the analogy in agentic is harness engineering now, which is and now validation engineering, loop engineering, however you want to describe it. But harnesses are architecture. They're the things that are the invariants that allow us to put our attention into something that our brains can handle, and allows us to do the work and validate it. So if we want agentic to be successful, we need to do longer arcs of development, and that becomes challenging. Just to recap some of my favorite quotes from Agile, user stories are placeholders for conversation. This is quite interesting in an agentic development cycle. If you've got a project and it has its sort of mission and its core goals, you can write fairly lightweight stories that can deliver a lot of functionality, and it will largely be aligned with your architecture and aligned with the business goals, and you can then validate it with end users, and then you can iterate on it. And so you can ship much more that is actually more accurate by thinner stories, being brought to the agent with a human in the loop on a more ambitious, sort of development arc. And it's counterintuitive. So, what do we see coming out of Amazon? Spec-driven development. What do we see organizations buying? Spec-driven development. Um, it's a terrible way to use agents for the most part. What you're doing is you're taking all of that agentic capability and you're pulling it back into sort of outdated waterfall development processes. Um, you need enough specification, so just enough specification to create the outcomes. But what you want to do is measure the realization of your intent, and that's been a very good way of describing it. You manage agentic systems based upon intent, and you can't manage it at a lower level. But if you run a team of six running for 8 weeks, building agentically, and with clear intent, uh, you can validate that you've achieved your system goals by running the software with users. Intent is a lot easier to validate at a higher level than actual code and requirements, and it's cheap to iterate if you have the right architecture and you're in the right neighborhood of the features you're trying to build. And so a lot of things invert. Working software is the primary source of truth. If this isn't how you're running agentic development, if your specs, those massive markdown files that you're generating from Figma files, and long meetings that get transcribed, that can all be very valuable. But it's there to validate mostly, and to extract what you're going to prompt with, and those prompts should be lighter weight to allow rapid iteration of working software. And then from the lean perspective, um, there's a lot of rabbit holes to fall into. It's similar, to traditional sort of lean agile development. Flow metrics matter far more than capacity metrics. If you can't move work through the system, it's broken, full stop. And that's where DORA metrics come into play. Your deployment frequency, your cycle time, your incident rate, your mean time to recovery, these still apply agentically. And most companies where I see DORA metrics being talked about at an executive level have no idea, what it actually means from a dev experience perspective, and they're not realized in the actual software development lifecycle because other invariants in the organization trump things that would allow for elite DORA metrics, which show a healthy software development lifecycle. Same thing applies to agentic. What I think is the opportunity for everyone is that these metrics aren't just good and better, they're essential. And you can't successfully build an agentic software development lifecycle without actually getting better at a lot of the fundamentals, that weren't really that measurable before. But now what you have is organizations are throwing spec-driven development into the org, and they're giving agents to the developers, and they're just telling them to build that way. And what happens is they're building more software that is unstable, that's not validated. They don't have clean swim lanes against other developers. They don't have the ability to understand the scope of what they're building because the software is being built so fast, it outpaces the developer's sort of experience. And so then we try to build bigger specs, and the specs become, it's a downward spiral into complexity and sort of madness that you're sitting here reading pull requests that make absolutely no sense because they're being generated from an overly complex spec that's trying to cover off every dimension of security, safety, behavior, and it just isn't sustainable or actually even executable. But going back to the traditional organizational invariants and incentives that derail any software development lifecycle, um, they are still there and they'll still impact agentic. The beauty of agentic, though, is you can move faster. So working software is easier to get, faster to get. And so you have all the same principles in a scaled lean agile sort of practice, but rather than it being, 6 to 9 months to validate, a core feature set, you can validate it in 6 to 9 weeks. Maybe not in shippable quality, but that's another core principle that we'll talk about. You have different goals, with agentic, and you're building. It's to build software, but another really important enablement is to capture requirements. And so, if you start in your software development lifecycle and your first phase is capturing requirements, you may build more, but you're not building for production. And then you're focused on building for production, and your agentic software development lifecycle shifts from that blueprinting and requirements capturing to foundational sort of quality, and then you're evolving in market, which is very similar to a traditional software system where you have incremental asks that you're implementing. So, invariants and incentives that hurt the SDLC, designs lead development. So everything is low trust and specified. Fancy new theories, micro front ends over mono repos. I have not seen a micro front end strategy that wasn't a mistake. And that's probably 95% of the situations because they're picked as a strategy, not as a solution to an existing problem. Regardless, that doesn't seem to move the needle. Micro front ends are still picking up. They solve a problem, and if you have them to solve that problem, you're good. If you have them as a strategy, you've probably made a terrible mistake. Microservices, very similar. They work in some cases. They're a terrible mistake in others. overstaffing early. People are just bumping into each other. Starting a project, if you don't have quality a quality SDLC and delivery metrics, and you have more than 25 people on a project, you've just probably tripled the effort that project's going to take, and you'll have multiple restarts. And so, you staff to platform and delivery outcomes, that we call that the 0 to 1, sort of platform build, and then you scale from 1 to 2 with teams, but you control by the metrics of the SDLC. If you overstaff early, you break everything. There's no way you can build cohesive, high functioning teams, get them trained up on a common methodology, manage the flow of information through an organization. And then, what happens is we'll just do more designs and more specs and more planning, and that doesn't really fix anything. Broken CI/CD pipelines in environments. If working software is going to be the source of truth, you need to be able to ship it. The horror stories and experiences we've had, with pipelines and environments, even up to last year, this year, this is something that is so solvable. It still remains horribly broken. People shutting down environments to save money because, there was a contract signed and they have a margin on it. So they're just going to shut down the environments overnight, and you're on a different time zone and you can't ship, among other things. And then just the stakeholdering in politics. And I use politics in a positive sense, like this is how you find alignment, but it's complex and there's a lot of different stakeholders. And, people then start worrying about the stakeholders. And that becomes an invariant and an incentive that trumps absolutely everything. But getting back to the core, continuously framing and shipping reliable software is the only real measure of a good SDLC. And but that is a impossible lift. So it just becomes the norm that we're going to work the way we work. Again, Agentic offers this glorious opportunity to ship faster, to make working software the source of truth, and that is, I think, probably the biggest opportunity. And then, how do you make it safe and reliable? That is, the core of the life cycle. I like to use Cynefin, which is complexity theory from Dave Snowden, as another, concept. Organizational transformation is complex. If you confuse whether something's complex or complicated, you end up in a world of pain. And a good question to apply to complex environments, which are not predictive to expert manipulation, is what's the evolutionary potential of the present moment? And that's how you navigate a complex system. Crossing the stream by feeling the stones, however you want to think about it. And then, for all of this, we're talking about requirements and the value of requirements. We collect them because they feel safe. This is a common psychological. We like more sort of failure of the human brain. We like more information. We get more confident. We think things are complicated, not complex. So we think we can plan through it. And we don't have an environment we trust to actually run a more progressive software development lifecycle. I mean, ultimately, backlogs are toxic, and burn them every chance you get. This is hard, and but the more often, I've seen backlogs just become the truth, and there is no more conversation, because every time you want to change something, the ripple effect is, you're working for the authority is the documentation. People aren't in charge anymore anywhere in the org. It's the backlog is in charge. Agentic helps a lot here as well. And so you can change the concept of a backlog. We started building context lakes, which are available for validation. So when we're building a backlog for a phase of work, we can generate, insights from the context lake. We can validate the context lake. We can scrutinize, against it. And then we get a much better, more accurate sort of backlog for the next phase of work. And then we build and we ship, and then we do it again. One of the things that we've then started to see is you don't want to over specify your backlog. So same principle, but this information is valuable because you can use it now, without it corrupting or hijacking attention and bandwidth. And it doesn't have to be debated. It doesn't have to be, um, it's not in charge anymore, I guess is the way to best describe it. You generate a backlog that everybody in the room agrees is the next most valuable thing. There's going to be a subsequent release where you're going to go into the more detailed releases. You're not being design driven, so you're not trying to ship screens that pull in all kinds of features that don't have to ship or can't ship together. But you have that context lake, you have designs that have been done, and you can validate. And that validation gives a lot of organizational trust. The backlog gets approved, you run agentically, you ship it, and then you have meetings. You can record those meetings, you can put them back into the context lake. So there's a lot there. But the backlog, is there to execute your next phase of work, and you cannot be enslaved to it. So, and agentic makes that better. So those are a couple of the things that make agentic better, but it still, has its other challenges and how it breaks everything. And so, we caught it's sort of out of order. We talked about a lot of this, but the massive backlog creation to feed agents, don't do it. Have a context lake that's sort of like there, and build the backlog, on demand. If there are requirements that have been gathered, don't use them in your backlog. Use them in your validation loop. You validate against the requirements, and then you generate another set, a new backlog to refine, to approve and refine. Usually, by the time you do that, a lot of those requirements weren't the most valuable thing. So you can push them back and do the next most valuable thing. And so you're not just pulling in low value work, and you're getting better feedback. You're getting live feedback with real data. Team context just collapses because you can't discuss things. So you have challenges understanding the full product scope. You have problems understanding the architecture. You have problems understanding the systems you're using. And, if you have to slow down to your team's learning, you've broken the value of agentic again. And you've gone from, a big productivity lift to no or negative productivity lift. Security and reliability. Um, Obviously, that's the most well-known one, with Mythos and all the CVEs and the impact. That will normalize because we'll get used to running the test suites against the code generally, but formal verification is very, very hard to do. And, there's so many different logic paths through code. There is a computational limit to that. And so once we've exhausted all the CVEs, there's still going to be a lot of reliability and security and safety engineering to be done. And so progress slows to your slowest decision making steps in the process, or to your slowest learning, steps in the process. And so on demand learning, again, the context lake, conversational, planning, locking the plan, narrowing the focus, because we can learn and be very confident about a small set of work. If we have to be confident about everything, on large projects, you have years to learn. And so you have this embedded expert knowledge in multiple people on the team. That collapses. That's gone. That doesn't exist anymore. And so that's a fundamental shift in tacit knowledge. And there's been some fascinating tacit knowledge studies, like in building a space shuttle. Like, the knowledge is in the people and the tacit knowledge. And once those people are gone, you can't just go to the documentation and rebuild a space shuttle. Western manufacturing, it's going to take a decade to rebuild it because of the tacit knowledge. And that's catastrophic, from a sovereignty in manufacturing. And, that's a problem. So when we think about like losing that tacit knowledge and not building it anymore, how do we mitigate that? And there's a couple of ways of doing that, and it really is rethinking, because the goal is our knowledge our context and our attention to use agents to build software. And without that, you can go and do a survey, and you will see a ton of different takes, right? So some people would argue that the agentic benefits are nil. There are none. Other people will argue that it's break even, 10%, 30%. Some will say 400%. Some will say 10x. But if you go back into the old agile literature, you'll see Jeff Sutherland in the Red Scrum book saying that highly effective teams are 1,000 times more productive than average teams. And everyone's heard of the 10x developer. And so, how do we get to 10x? Is that possible? Is that the goal? If you push for it, you're going to break things because you're going to have the wrong incentives and the wrong organizational sort of norms. If you evolve to it, you can see and measure the productivity. It depends on the type of software, the complexity of the software, the domain, the team, the knowledge of the team in the domain. Like that could be impossible option or goal. In other cases, it might be quite easy. And then we're building, domain knowledge as assets to feed in the project. So pattern libraries and, semantic architectural guides, but we still need to, have the application of them done effectively into projects. So I'll give the case study of standing up a pharmacy rebuild. Pharmacies are regulated. They're highly complex systems, and they are, not probably your first choice, like for building a system agentically. But having good developers and thinking through the SDLC and taking a year of experience working on small projects, we felt confident that we could achieve this. And moving through, the first thing is people matter more than agents. And I talked with a CTO about a year ago from a European private equity fund who was struggling with his team because he found that people sort of got stuck on their first agentic operating model. So there was people who would refuse to use it, period. The people who were using Cursor, were happy with Cursor. They refused to use Claude. So this is like June, July of last year. And then, moving through, um, he felt that agentic was a 4x improvement and Cursor was a 10% improvement. So going back to that slide, and he wanted to get his developers working agentically, and he couldn't get them to do that. And he was looking for partners to pair with them to get the teams transformed. So that would be similar to, the Target Dojo or Pivotal Labs. And, how do you do immersive transformation of a team? Target ran their dojo and they spun up all these highly effective agile teams. That worked well because it was immersive within the organization. All Pivotal Lab transformations almost all dissipated, as soon as the teams were back in their organization, because the organizational invariance and incentives would destroy any agility that was, temporarily put into the team. And most of the projects that were done for the transformation were low hanging fruit that don't actually model most enterprise projects. And so, like, if you look at the press releases, from yesteryear, Ford and BMO and other companies, working with Pivotal, there was absolutely no transfer of knowledge. So the target model definitely worked better. So people matter more than agents. And so thinking about staffing and we set up a rule for complex enterprise projects. We want 400 hours of agentic airtime. There's a lot that people need to learn and go through. It's becoming a little bit less because now we actually understand, how to use cascading agents and sub agents and skills and, do the harnesses. 6 months ago, none of that was clear and everyone was running around with bloated context files. And also the models have gotten better at managing larger context windows, but there's still some hard limits. So we went from people having 1,000-line Claude files to like trying to have them less than 200 lines, and then realizing that actually empty agents outperform agents with context for a lot of things because we want a fresh take. So if you're going to do a security, agentic process, you want to be spinning up new agents and you want to fan them out. So we've all, seen that sort of move to fan out dynamic workflows. And I think, if we think about context and understanding and how humans work with code and learning, there's a lot of corollaries and a lot of similarities. And so it does feel like we've hit um, a plateau in agentic software development life cycles, where this is the verifiable sort of you can think about it and understand it, and it's sort of the right model. And whether there's going to be massive improvements, there'll be more improvements for sure, and better harnesses and better coordination. But the reinforcement learning is starting to wobble a little bit. um, I can't bear to chat with Claude anymore because it's just so inane in its language, and if I see load bearing in one more document, I'll probably lose my mind. It's sort of hit a level of inanity, or just this complex inscrutable take, because it's actually trying to define the solution more comprehensively for more autonomous longer running agents. But that doesn't really work from a human cognition perspective because it's blowing out our context window and we have no idea what it's talking about. So you need to learn to pair with an agent, instincts on outcomes, local harness engineering, comfort under specking agents, learning to avoid agentic burnout. Infrastructure work is separate, similar though, but you want to manage the development harnesses, manage the validation harnesses, move requirements to the right, team norms. These things are important. And so what we've evolved over the last year, and it's still evolving. We had 3 people, and now we're actually up to 5. We're probably going to hit 6, and it's where we put attention and what the problems are. We talked about complexity, getting the requirements, figuring out what needs to be built, how to specify it, tacit knowledge. Anything you can move to validation over requirements is a massive win. And that's sort of the heart of agile with working software. It's the only way to build an effective agentic software development lifecycle. Anything else is performative. Show. It's not really real or applicable. And so we came up with the concept of the agentic product lead, who is leaning into the product needs and into the business and specifying the product outcomes and doing product thinking. Product managers, they can work really well and work as an agentic coder, but they're not able to review pull requests with the same level of scrutiny or understand where code reviews go. And even good front end engineers or back end engineers, they worked on teams and they were not the infrastructure engineers. They were working on a module in a language that they had 6 months to get up to speed on, and that's gone, right? So it's a different skill set and it's a different role. But an agentic product engineer can build good things with multiple languages. They can read it. They know what good looks like. But you can't make them also the infrastructure engineer and the architect. Things are moving too fast. So that's where the agentic systems engineer comes in. And these are the sort of unicorns and the people who can see around corners. They have 10, 20, 30 years of experience. This is where we see a lot of industry leaders going back into IC roles. This is like being a leader of people. Like you've got all these agents, these systems, you're looking at second and third order concerns, and you're dealing with complex problems, not complicated. And then you've got design still, like what is good design, and the design is about product and company outcomes. Can you build a good design system? Can you verify the design? So setting the sort of the design language and process. And then where we didn't really see uh, how it was going to manifest. But when you have, it's like a large team, you have the product person dealing with vastly more product information because you're moving faster. Your product design lead is building design systems and higher order design enablement. Your agentic product engineers can design quite effectively because they're consuming a design system and product intent. And so you don't want to be feeding them Figma designs to implement a screen. You want them to be building to a semantic design description that sort of is executed against an agentically enabled design system. Figma is one of the most toxic sort of blockers in agentic software development lifecycle. When we talked about slowing down to the unit of decision making, that is important. But if you want to scale an agentic system, you want your design talent going into the design system and whatever they use, Figma, PenPot, if they vibe code it, Claude Design, it's all great. Like design is a creative, skill thing. It's not a dependency, right? So they need to agentically enable the rest of the team to work and execute their design vision agentically. And so it's a big shift in the design lifecycle. And you don't want to be blocking on it. So you want to be enabling with it. And then the agentic delivery lead. You have so much going on at scale. You have a 5-person team, but you need to think of it as a 25-person team, and that's a lot of coordination. A lot of validation. A lot of making sure that everything's working, and it's different than product. And there's just so much. So planning 12 weeks of work, we might generate 200 and plus units of work. Those units of work are, we look at it as, and that's this is sort of one of the SDLC considerations. An engineer or a product person, you need to be able to think and reason about the work you're doing. And so when I build stories to feed a backlog, I usually look to have a story encompass 4 to 6 weeks of a single developer working. Now, historically, a story would be 1 to 2 days of developer time. 2 days are too much. Break it down, ship it. You can't do that if you want agentic, longer running agents. And because the decision making is being done by the agent while it's building, if you think of what a developer does in 4 to 6 weeks and what traditionally would be a deliverable, and we've run a lot of 6 week startup projects, 2 developers, 3 developers, 6 weeks. We usually try to ship things into prod in less than 12 weeks, regardless of the complexity of the project. And so we're, really drilling down on those flow metrics. 4 to 6 weeks, I can think about, I can reason. It's actually more comfortable to spend time and think about it. And so 4 to 6 weeks. So now we have, 2 days of developer time is, going to deliver 4 to 6 weeks of say, work from a story perspective. But there's a lot of extra work and follow on work that will come with it. That sort of like notionally, we think of it in terms of what can we manage and put our attention on. And so that's a breakdown way of doing that. And that's just a lot of work in progress that clears out quickly. But that agentic delivery lead is a role that is a profoundly important one, because you have to think about where people spend their attention much more carefully. And if I'm working on a project, they say, hey, let's just have the senior engineer be the scrum master, or we'll rotate it and roll it around, or the product lead, that collapses just because of cognitive load. And so, the 5 pillars of attention for an agentic software delivery lifecycle, cognitive load is the most important thing. We need to be able to manage our attention. The comfort with ambiguity in agents. The agent is a partner in thinking. Architectural integrity. So we crossed a threshold in December where agents write better code than most people. They do much worse architecture, and you can build good front end code on a catastrophic architecture that is going to have lots of issues and bugs. It's good front end code. The core domain model is a disaster. And these are things like order management systems, ledgers, accounting practices, long running transactions. These are the complex things, sagas, that are very hard to do in software. And where you see durability and where people go to platforms because of that complexity, are things that are like financial systems, accounting systems, e-commerce systems, because order management is really complicated. With discounts and refunds and partial refunds, and there's a architectural problem there. And then system safety, and then system reliability. And code quality doesn't actually manage matter outside of the above, because if you have system safety and system reliability, it means that you're okay with the code. And the reason we're writing it this way is thinking of this as a coding exercise is the wrong lens. This is a product engineering or development exercise, and you want code quality, as a well, you don't want code quality. You want system safety and system reliability. Code quality is how we've traditionally done it. If there are other means to doing it, other architectures, other practices, then you want to do that. And so one way we do that in the SDLC is, we actually invert the complexity for the agent. And this is essential. So we pick our technology based upon developer cognitive load. And we pick, what they work on based upon that. And, we differentiate the roles. But as we got into more agile, we wanted, vertical slices. As a result, we're picking the wrong tech stack based upon what we know. And so almost every Y Combinator startup and almost every um, vibe coded project and lovable project, they're all Vercel plus Supabase. Uh, that's a terrible architecture. It's absolutely horrendous. You're taking a front end technology and slapping it on a database that's 10 open source modules stapled together. You've got no sovereignty. You can't bring in other languages. You have no ability to leverage infrastructure that you're probably going to need down the road. And you're doing it because that's what's available to the engineer and their knowledge. And so if you're doing agentic development, though, and you're working with open source systems that have a lot of training data, then all of a sudden that doesn't matter. And this is where it gets counterintuitive. If you're working and building a Next.js app or React app or TanStack or whatever, and it does not have a queue, you're going to implement a queue, and a poor one. If it doesn't have transactions, you're going to implement transactions, albeit a poor one. Distributed transactions, long running transactions. By the time you realize what you've done, you've implemented all of the attack surface areas into your application, because you have a lot of complex code you can't think about. Role-based access control, authorization versus authentication, token management. So like generating a token to allow a transaction on a remote system that automatically times out, in 6 minutes. So there's no long running permissions to allow an errant intruder to hijack, a token, and, sort of you're removing surface areas at the infrastructure layer. So if we go back to here, system safety and system reliability, safety is a very specific term in process safety management. Chemicals, oil and gas, cars, means no harm. And if your system fails but it doesn't do any harm, that's good. And sometimes we have systems fail open because there's no harm risk. Sometimes we have to have them fail open because there would be harm if they shut down. Sometimes they fail closed, so the system stops. These are system design sort of issues. But if your system is safe, and you can extend that into, physical harm, but also financial harm, and if you do that, then your system is not safe if it shuts down your business for a day. So reliability becomes sort of a safety consideration. But trying to create safety by perfect reliability is going to fail, particularly with agents, because agents will always fail. And the reason that we're very sensitive to this in process safety is even if you have one failure, every 50 years in a chemical plant, but that failure blows up half a town and kills 500 people, that's not acceptable. The machines all fail all the time. You have preventive maintenance, and you have all the reliability engineering, and that's a separate discipline. But reliability and safety engineering are completely separate for that reason. And so now you bring in temporal for long running, durable execution, Kafka for events, it's replayable. You have Postgres. If you say I need to have immutable records, you can use a Postgres write only table. You can set up an S3 bucket that's write only. You can pull together the infrastructure. So you can have a write only S3 bucket, and you can use Garage or RustFS or Seaweed for that, or Amazon AWS. Generally, because we want to pull infrastructure to agentic development, we lean heavily towards Kubernetes and sort of cloud native, because that allows developers to be able to build immediately, on a technology. And the reason you want open source, which that's Kubernetes, top to bottom, is that's where the training data is. So for the pharmacy project we're talking about, we were talking about SQL Server or Postgres. Postgres has 8 times the training data. It's not even close. Like, oh, it's a Microsoft shop. We're working from the traditional pre-agentic human cognitive load and learning curve. That is already broken. So we need to sort of have the agents learn and execute, and then we have to figure out how to have humans learn and execute in a way that is a fun way to build things, but also achieves our business objectives. So infrastructure first. When you have infrastructure, everything becomes more declarative. Your validation surface, is well understood for durable execution, for events, for authorization. You haven't implemented a half-assed authorization system, or just spewed a whole bunch of random stuff into, Supabase RLS. You've got something that is way harder to use, except it's not anymore. It's easier to use. And so a more complicated architecture actually has less cognitive load for the agents and for the humans, which is a counterintuitive agentic SDLC consideration. So most of the projects I work on now, I will set the infrastructure with that in mind. I want to, build for validation friendly surfaces. And, decomposing the system is different. And so, when you think about how we would used to build systems, and I left this sort of generic, but we used to always build horizontally. We would build the object relational sort of engine, we'd build the API, then we'd start building the front end, capabilities, the modules, and then we'd build the user interface before we could integrate. 18 months had passed, and we finally have an end-to-end, sort of running system. It doesn't scale. We built the wrong thing. We weren't able to validate when we actually have to extend it. The architecture is wrong. There's so many failures, and a lot of the very, very large, famous software failures came from this world. And then you've got the sort of the vertical, sort of agile decomposition, where you're taking slices of a system. And so you do a just enough architecture, and then you deliver your horizontal, your vertical slices against it. This is where it gets interesting. And so if I am working here on this first vertical feature, and I'm building, onboarding, and I'm bringing on users, I'm setting their authorization, and I got to check to make sure there's no accidental privilege escalation. I need to make sure that it's following, the system architecture. But as I'm doing that, all of a sudden I'm getting, you know, um, feedback from the code review agent that I violated security policy, 5.2. I have no idea what that means. So now I got to go read that. Well, I've never done security, so now I got to learn security. And now I'm reading this, and now I'm looping through code reviews, and Claude is sort of coming up with all kinds of things, and I'm just spending days just looping through a fairly simple feature because I'm responsible for it. And this PR is going to be reviewed by someone. They're going to do the same thing. The thing is, at this scale, for this amount of code being written that's cutting across this infrastructure, the people doing the pull requests, they're not qualified, and they're not going to be able to be qualified. They're not going to be able to learn fast enough. And so this breaks. And so, PR based continuous integration doesn't work. But there are other ways of thinking about the team. And so my job is to build and deliver features. I want to get a first pass validation of my feature. But someone else is responsible for the test harness, for the safety model, for the security model, and they are specialized. And so if you have someone working and they finish a feature and they do a pull request and it gets that first level of CI/CD pass, that should be sufficient for them to be done with it. And now it moves to a specialist from a security perspective, because the amount of knowledge required to run the security harness, the safety harness, to understand it, to modify it, to guide it, it's a specialized job because of the scale. So we're now seeing a infrastructure first development SDLC, but we're also putting people on long running streams. So if I were to describe this, and I'll just take a pharmacy as an example. So we have the environments and the infrastructure. So that's one engineer owning it, building it, sort of pipelines. Then we have the design system. Similar thing. We have two people on it, one designer, one developer. They're owning it. It's a cross-cutting concern. And then we have our sort of APIs and our, sort of our surface area, of the back end. So we have our back end sort of architecture and infrastructure, and we have one person owning that. And now we have, feature engineers who are building against the product vision, and they're shipping, within their knowledge and with their learning and within their cognitive load. And now we have a system that actually works. And now we can start also building much more interesting and extravagant validation harnesses and test harnesses. The product lead is actually working with the sort of the infrastructure team to have the validation harness running in the context lake. And so that's our new sort of architecture where we're optimizing for that challenge, that SDLC. And with that, I actually don't know what we have here. So let me look. And yes. Yeah. So all right. So if you have any questions, if you want to post to the message, or I think we can actually unmute you if you want to sort of ask anything. This was a fairly ambitious talk, but I wanted to get to the, how do you actually get and plan for an agentic transformation in SDLC? And so I want to cover the foundations, and then where you end up on the architecture and the practices. We will make the talk available, as well as a follow-up sort of white paper, sort of that goes into more detail on the specifics. Well, with that, we'll wrap it up and give everyone a couple of minutes back. And thank you all for joining. If you have any questions, feel free to follow up. I put my email here, and we'll have more detail, so that'll be helpful for you to sort of see if this is useful. And if you have any follow up questions, we're always happy to chat. We learn as much talking to you as hopefully you learn from us. So happy to talk anytime with no agenda and nothing to promote. So thank you all.